Hello everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on squares of a sorted array. The problem states that we are given a sorted array in non-decreasing order, which is in increasing order, and we need to return the squares of each element, that too in a sorted fashion. The key observation is that we may also contain negative numbers when squared can result in a larger value. We need to consider this. So the brute force approach goes like we have to square each and every element and we will sort the resultant array. For that, we need a new list named result till the length of the given array, and let's iterate through the entire array. And in the resultant array, let's put the square of the current number. Now at the end, let's sort it. And then return. Let's run the code. It is working, but the time complexity for this would be n log n, because we are also sorting the entire list and we are also using a for loop, and the space complexity would be O of n because of the extra space that we used. So for the optimized approach, here the key observation should be the largest square will come from either end of the array, and the negative numbers when squared can become large. So we use 2 pointers, one at the start and one at the end, and we will fill the result array from left to right or from right to left. For that, we need a resultant array. Let's also take start length in a variable n. Now that we are using 2 pointers, we need 2 pointers, one which is left starting from the initial index and right would start from n minus 1. We also need one more variable called index which starts from n minus 1. Now let's take a while loop, and if the left is less than or equals to right, now we need to find out the left square and right square. Left square is nothing but the square of the number at left index, and right square is nothing but square of the numbers at right index. Now if left square is let's consider greater than right square, then we need to put it in the result. Let's decrement it, post decrement, and we will assign it, and then we will increment the left pointer. Otherwise post decrement, and we will assign it the right square, and then we will decrement right pointer. Now at the end, let's return the result. Let's run the code. It is working. Let's submit it. It is accepted. So for example, if you consider this input, initially it would compare -4 square because the left pointer is at the start of the index and the right pointer is at the end of the index, end of the array. First it will consider -4 square and 10 square, which is 16 and 100. Since this is greater, since the right square is greater, it will go into the else block and we will update the result and the right pointer decrements. So the right pointer would be here and the left pointer is still there. Now we will consider -4 square and 3 square, which is 16 and 9. Since this is greater, we would update it in the result and we would increment the left pointer. Now the left pointer is here and right pointer is still here. -1 square and 3 square. So we will place 9 in the result and we would decrement this. Now -1 square and 0 square. Now we would place -1 square in the result and we would place 1. And at the end we would place 0 square, which is 0. So after squaring these, the arrays would become this. So the edge cases are, it works for negative numbers, it works when all the values are positive or zeros, and it handles single element arrays too, because we are using equal to condition too, so it will handle single array condition. Now the time complexity would be O of n because we are doing everything in a single pass, and the space complexity would be O of n because you're using an extra space in the form of array. So since the array is already sorted, I used 2 pointers for both the ends and I filled the result array from right to left based on the larger square. So that is it for today's problem. In the next problem, we will continue with another 2 pointers problem named merge sorted array. Thank you for watching.